Hello, this is a work through of Level 2 Mathematics and Statistics 2025 examination 91262, apply calculus methods in solving problems. I've already produced videos for questions 1 and 2, so we'll be doing question 3. There's 4 parts, A, B, C and D today. So let's make a start and look at those. Here's question 3. A function f of x is given by this quadratic 2x squared minus 7x minus 20. Find the coordinate of the point of the curve where the gradient of f of x is equal to 3. We've already looked at these. When a question asks for the gradient, it's basically telling us to look at the derivative. So this question really says, where is f prime of x, the derivative of this function, equal to 3? So that's the problem we need to solve. So let's just go about that. We need to differentiate. You differentiate by multiplying the power in front, 4x, and reduce the power by 1. So 2 goes down to 1. We don't write the 1 in. When it's a linear term, it's just the coefficient. It's the same thing, multiply by 1, and x to the 0 is 1. Little simplification there, and then here the same thing. This is x to the 0, and 0 times anything is 0. So this term vanishes when we differentiate it. We want to solve when is that equal to 3. Add 7 to both sides, so 4x equal to 10. X is 10 over 4, which is 5 over 2. And we're done very, very quickly for question 3a. B, we've got a triangle that's expanding, so something's making us go from here to here, such that the base is always 4 times greater than its perpendicular height. So if we call the base B, that tells us the base is 4h. As shown in the diagram. Find the rate of change of the area of the triangle with respect to its vertical height. That's a derivative. Rate of change, that's a derivative. And it's the derivative of the area, which we'll call A, with respect to the height. So it's telling us the area is some function of the height. We can write down the area. Area is half base times height, which is half base is 4 times the height. So 4 over 2 is 2, so this is 2h squared will give us the area. We want the derivative, dA by dH. That's the rate of change of the area with respect to h, the height. Differentiate, multiply, so 2 2s are 4, h to the power of 1. So that's the derivative. We need to know what h is in order to get a value for this, and there's information in the question. Information here, the area of the triangle is equal to 98 centimeters squared. So we can use this area formula. Area is 98 is 2h squared. Divide by 2, 49 is equal to h squared. Square root h is equal to 7. Technically plus or minus 7, but when we've got a physical problem, we can't have a distance of negative 7. Some mechanics questions, negative 7 would be back in the opposite direction, but that doesn't apply to a triangle. It's got a height. The area doesn't change if we had a negative at any rate. The height is the absolute value. It's always positive. So we go back over here and we find the rate of change, dA by dH, evaluated when h equals 7 is equal to 4 times 7, which is 28. And we're done with part B. Part C, Evie is designing a lidless rectangular cuboid container. Cuboid, that just means it's a box. Right angles for all of the all of the angles all around the box. That's what a cuboid is. It's a box with square sides, square meaning at right angles. We want to find the maximum volume of the box and prove that the volume is maximum using calculus. There's a constraint. The container is made of a maximum of 4.32 meters squared of material. It's reasonably trivial to reason that if we don't use all the material, we can't possibly have a maximum. We could always extend the length. Everything else being equal, say we can extend the length and we'll get a bigger volume with the extra material. So let's write out some equations. We're trying to maximize the volume, and the volume is equal to the length times the width times the height. I did gloss over. She wants the box width to be twice its height, so similar to the last question, but this time it's 2. The width is equal to 2h. So we can rearrange that. We can substitute for w in this equation with 2h. So it's length times 2h times h. Put the 2 in front, 2l times h squared. So now we've got a volume in terms of just the length and the height. We can work out the length in terms of the height by using this constraint. That's the amount of material we've got. That material, meters squared, is the area of all of the sides and the base. So the area, which is the amount of material, there is a U in there somewhere. The area is equal to the length times the height. That's this side. But there's another one on the back, so there's 2 of those, plus the width times the height. But again, there's 2 of those. Let's do them in a different color. And we can do this in a different color too. Plus the width times the height. And again, there's 2 of those. And then there's the base down here, which is the width times the length. Now we use this fact. This is 2 length times the height plus 2. The width is twice the height. The width is twice the height. 2 length height, 2 length height. That means there's 4 of those, plus 4 times h squared. And we know that that amount of material has to be 4.32 meters squared. So we can rearrange this to make L the subject. Therefore, L equals, if I divide everything by 4, 1.08, 4 goes into here. This, dividing this by 4 will be just h squared. Shift that over the other side, minus h squared. We're divided by the 4, so we've got L here times h, and then divide everything by h. That will give us a formula for the length in terms of h. So now our volume, which is 2 times L, which is 1.08 minus h squared over h, times h squared. We can cancel the h with one of the h's and h squared and just get left with h. We can multiply this out. I'll leave the 2 out the front, so it's h times this, 1.08 h minus h cubed Often we'd factorize, but when we're going to differentiate, it's going to be easier to differentiate these term by term if it's multiplied out. So now we differentiate to try and find a maximum. dv by dh, so it's 2 times this linear term, we just get 1.08, and this term multiplied by the power, reduce the power by 1, and we want that to be 0 for a stationary point, which might be a maximum, might be a minimum, could be a point of inflection, but we need to investigate that at any rate, so we'll look at that. So this is equal to 0, divide by 2, that's still 0, shift the 3h squared onto the other side, so we get 3h squared is equal to 1.08, so h squared is 1.808 divided by 3, 3's into 10 is 3, and 3's into 18 is 6, therefore h is 0.6, and that's in meters. Plus or minus when you're taking a square root, but again, lengths of sides can't be negative, so we have to use the positive solution. What's the volume? We've got a formula for that. Here it is. 2 times 1.08 h minus h cubed. So that's 2 times 1.08 times 0.6 minus 0.6 cubed. We can do this on a calculator. 2, we can just multiply it out. 6 8s are 48. 6 zeros are 0. 6 1s are 6, which is 1, 2, 3. There's 3 points. 0.684 minus. This is 6 cubed is 36 times 6. 6 1s are 6. 6 3s are 18. 21.216. So it's 2 times 2, 3, 4, to 0.864 meters cubed. That's our volume. So that's the first part, find the maximum volume in the box given the limitations above. Prove that the volume is a maximum using calculus. One way to do that is to find the second derivative of the volume with respect to h. So we differentiate this expression here. We want to differentiate this one. So it's going to have 2 outside. Um, 1.08 h was going to give us 1.08. We're differentiating the derivative. 1.08, there's no h in there. This is just a constant, we lose that. So it's just this term, put the 2 in front, 2 3s are 6, h with a minus sign. 2 times minus 6h. This is multiplied. That's what's meant by those brackets. H is positive. We don't actually care what the value of this is. We know it's going to be negative, so we know it's going to be less than 0, and that implies that we've got a maximum. And we are done for part C. So finally part D. Here we've got a function. Our functions are quartic, power of 4. We're told that k is a positive constant. That's going to be useful in determining the details of the answer, and using calculus determine the regions where the function is decreasing. Function is decreasing. The derivative tells us about the gradient. A function is decreasing when the gradient is less than 0. So that's basically the problem we're trying to solve here. So we calculate the derivative. Power in front, 4x cubed divided by 4. 4 over 4 is just 1, plus 3k minus 3x squared divided by 3. The 3, so let's write them in and cancel them out in one almost breath. And then minus 2 times 3kx over 2. This one cancels. And the constant that vanishes when you take a derivative. So the first thing I think you can notice is we've got an x in all of these terms, so we can factor that out. So we get x times x squared plus k minus 3x minus 3k. Ideally, we want to factorize this bracket. That can be done because it's two numbers that multiply to negative 3k and add to k minus 3. Well, they're staring right at us because if I multiply k and minus 3, I get minus 3k. And obviously, if I add them, I get k minus 3. So this is x plus k, x minus 3. X squared, x times minus 3, minus 3x, k times x, kx, and then minus 3k, all done. And we want to know when this is positive or negative, or we want to know specifically when it's negative. So what we can do is we can make up a table of values. Let's do it in a different color. 0, 3, negative k. We get x equals 0 here, x equals negative k here, x equals 3. Those values this is x and this is our derivative. At each of those values we get a derivative of 0. We know that negative k is below 0 because the question told us k was positive. So negative k must be negative. And what we want to find out is what the value of this is, not the exact value, but whether it's positive or negative in all of the intervals that are marked on here. So yeah, let's just use a different color. So if we have x is bigger than 3, if you look at all these terms, actually some people expand this table. Let's do the x plus k a little neater. So if x is negative k, this is negative. Negative k plus k is 0, and negative k minus 3 is negative. So when you multiply them, you get 0. If x is equal to 0, this is 0. 0 plus k, k was bigger than 0, so this is positive. 0 minus 3 is negative. But when you multiply them together, because you've got a 0, you get 0. X is equal to 3, this is positive. 3 plus something positive, that's positive as well. And 3 minus 3 is 0. So multiply them together, you get 0. So you can fill out all of these values. So x is bigger than 3, x will be positive. Something bigger than 3 plus a positive number, that's going to be positive. Something bigger than 3, take away 3, that will also be positive. So we've got 3 positive numbers which we're multiplying together. So this will definitely be positive. let's put that conclusion in a different colour. If we've got x between 0 and 3, x is positive. Something positive plus k will also be positive. But if I take away 3, for example, 2 take away 3, I get a negative. So 2 positives and a negative, that means we will get negative value in here. If I've got negative k less than x less than 0, x, it's less than 0, so it's negative. X plus k, well, right at the end, if I add that, I get 0. If I get something bigger than negative k, so don't know what k is, so, but if I add k on, it's definitely going to get past 0, so it'll be positive. And then something negative, take away 3, that's definitely going to be negative. So 2 negatives is a positive times a positive. So I will definitely have a positive derivative here. And finally, if x is less than negative k, or negative k is negative, something smaller that's definitely going to be negative. If I add on k, I'm not going to get up to 0, so that will still be negative. And if I take off 3 from a negative number, I'm going to be negative. Negative times negative times negative, that definitely gives me a negative. I like to draw little pictures. So positive slope, 0 slope, negative slope, 0 slope, negative slope, positive slope then, 0 slope and negative slope. So this sort of table tells you a lot, much more than we need. So we know that this point here is going to be a minimum because we're going down, flat, up, up, flat, down. This one here at x equals 0 will be a maximum. Down, flat, up. This will be a minimum. That's not required to answer this question. All that's required is when are we going down? Well, we're going down, decreasing for x less than negative k and for 0 less than x less than 3 in here. Negative. And that's part D done of question 3. So any questions, put them in the comments and I'll get back to them when I can. Otherwise, enjoy doing your mathematics and I'll see you next time with another tutorial.